Lesson 71 is going to combine lesson 70 with this. Today what you'll do is you'll be using those ratios to find surface area and volume of larger figures. Yesterday you found out the ratios of the scale factor ratio. You found out the surface area ratio and the volume ratio. Surface area was squared compared to the scale factor, and volume was cubed in comparison to the scale factor. In example 7, they give us the scale factor, and then we have to use the information given from the smaller figure. It says the surface area and volume of the smaller figure are given. We need to find the surface area and volume of the large figure. So first thing that we'll do is we'll go ahead and find out the surface area of the large figure. Well, we would find out the surface area of the large figure by converting your scale factor into a surface area ratio. So we have the surface area ratio here. To figure out the surface area ratio, you would square both components. So you would have your 5/6 ratio, square both components, and we get 25 over 36. Now we have to find, we know we have a small figure and a large figure. That's kind of what your ratio would be. Obviously 25 would be small, 36 would be the large, equals. We are given the smaller surface area, so that would be on top with the smaller ratio. So we have 275 on top over x, what you just set up as a proportion. You would cross multiply and divide, and you would find out the surface area of the larger figure, which would be 396 centimeters squared. Now we need to go ahead and find the volume of the larger figure. So in order to figure out volume, we need to kind of compare apples to apples here. We need to have a volume ratio. Makes sense. Surface area ratio to find a surface area, a volume ratio to find volume. So what we'll start off with here is, again, using the scale factor, 5/6. You need a volume ratio. Well, your volume ratio is going to be cubed, so I'm going to cube each of those, and we get 125 over 216. Small figure, large figure. 125 over 216 equals something, and remember the small volume is given, that is 3,000, so that's on the top. That we have listed, small is on top, large is on the bottom, large is unknown. Go ahead, cross multiply, divide. We figure out that the volume of the large figure is 5,184 centimeters cubed. That being said, example 8 and 9 are pretty similar. Some information about the surface area and volume of two similar figures has been given. Find the missing value. We know, obviously, by looking at it, it looks like solid 1 would be smaller than solid 2. So you could say, really, almost this is small figure, this is large figure, and you could kind of attack it like that. Now remember, when you do this, you need to keep in mind the surface area, volume, scale factor ratios that you have. Well, what we have a comparison here is we need to figure out the surface area ratio. Reason why I chose surface area ratio is because I know the surface area of both of these figures. I know that one is 12 and one is 972. So remember, surface area ratio is really a squared over b squared. And I have really, these values are already squared because they're a surface area. These are squared, so it's really 12 over 972. I need to go ahead and reduce 12 over 972. That would give me 1 over 81. Remember, now this is a surface area ratio. So in order to find out a scale factor, I would have to actually take this value here, which is an area square root. So what I mean there is this is an area, so you need to actually square root those values. Once you square root those values and you square root the top here and square root the bottom, you'd find out that your scale factor is 1 over 9. So now you're going to use this scale factor, and what we need to solve for is a volume. Now, in order to find that volume, we need to compare apples to apples here. So we wouldn't want to use an area ratio. We wouldn't want to use a scale factor ratio. So why did we figure out scale factor ratio? Well, we can use scale factor ratio to figure out the volume ratio. And here's how you'd figure out the volume ratio that we need in order to figure out the volume. Remember, volume ratio is really a cubed over b cubed. So you really have 1 and 9, your scale factors, which you need to go ahead and cube them both to figure out the volume ratio, which would be 1 over 729. We now would use our scale factor ratio, or I should say our volume ratio, 1 over 729, equals something. Well, if we scroll back up to the top, remember here, we are given the large one, or we called it large. We could simply call this also figure 1 and figure 2 if you don't know which one's large and small. So we had small over large, or figure 1 over figure 2. So when I set this up down below, I can call this figure 1 and this figure 2. And we know that the volume of figure 1 is 26. So 26 for fig 1. Unknown is figure 2. X. Cross multiply and divide, and we find out the volume of figure 2 is 18,954 miles cubed. Example 9 is very similar to example 8, except this time you are given volume. You know both components for the volume. So if you know both components in volume, you can take that, much similar to example 8 where they give you the surface area. So go ahead and figure out the scale factor first. Go ahead, pause video, find the scale factor. For starters, to figure out scale factor, you need to find the volume ratio. I'll go ahead and take figure 1 and figure 2, use the volumes, reduce this fraction that we are given, or ratio given. We would kind of come up with 1/27. Now remember, this is talking about a volume ratio, so those values are basically, if you think about it, they're units cubed. So in order to get rid of a cube, we have to use the cube root. Once I cube root the numerator and the denominator, the cube root of 1 is 1. The cube root of 27 is 9. I now have my scale factor. Excuse me, the cube root of 27 there would be 3. So you now have that scale factor that you need to find out. And then we can use that scale factor and can go ahead and find out the surface area ratio. So finding that surface area ratio will look something similar to like this. I'd use my scale factor, square A and B, and my surface area ratio would be 1/9. Using my surface area ratio, I can now find out that surface area of figure 2. So I'll go ahead and say that this is figure 1 again over figure 2. Here's my surface area ratio of 1/9. Figure 1, surface area is known, that is 99. Figure 2 is what is unknown, that is x. Cross multiply and divide, and you would find out that the surface area of figure 2 is going to be 891 yards squared. This will conclude lesson 71